Okay, so today we're going to be doing a little trapezoidal rule. And basically this is just a method of approximating an integral, which is also just the area under a curve. So let's start. Here's the basic formula. You have an integral over an interval a to b, and the trapezoidal rule is just saying that it's equal to, or approximately equal to, h divided by 2 times the function value at x0 plus 2 times the function value at x1 plus 2 times the function value is x2, and that just continues on till it's 2 times the function value of xn minus 1 plus no 2, just f at xn. Okay, and here h is just equal to the interval here, b minus a, divided by n subperiods. So I'm just going to illustrate this with an example. There's two basic methods they could require you to use to answer. So either they would give you the integral itself with the function, in which case you would just have to plug in x values to get the function values to use over here, or they would just straight up give you like the x values and the function values, in which case you would just have to plug it in. So let's just assume for the purpose of our first example that they gave you the function values and the x values. So probably be in a table format that they'd give you them. Okay, so say the x values they give you is just 1, 2, 3, and corresponding function values 5, 6, 7. You don't really need to know what the function is as long as they just give you the values. So say they ask you to integrate over the interval x is equal to 3 to 1. So our h here would just be, again, we know from the formula, it's just b minus a divided by n, where a and b are the interval. And so that would just be, in this case, 3 minus 1 divided by n subperiods. So we have 2 subperiods here. Okay? So 3 minus 1 is just 2 divided by 2 is just equal to 1. Okay, so here we know this first value is going to be our x0, and this is going to be our x1, this is going to be our x2. So then the corresponding function values are going to be obviously f at x0, f at x1, and f at x2. So now it's just a matter of plugging in our values to the formula. So just to remind you of the formula here. Okay? So it's going to be equal to, or approximately equal to, h divided by 2, so 1 divided by 2, times the function value at x0, which we see here is 5, plus 2 times the function value at x1, which is 6, and then we're at our last function value, so we don't need to multiply by anything, it's just plus 7. Okay, so here is just 5 plus 12 is 17, plus 7 is 24, divided by 2 is 12, and there's your answer. It's pretty easy, it's just a matter of plugging stuff into the formula.